Hello, in this video, we will look at modularizing code. Modularizing makes the code easy to maintain and easy to debug, and enables the code to be reused. We have presented the program for finding greatest common divisor in chapter 5. The code is all put in the main function. It is not reusable. Now we are going to define a function for returning the greatest common divisor between two integers. And then we're going to reuse it. So now this is the function for GCD between N1 and N2. So this is a return GCD. And here's the test program. Prompt the user to enter two integers N1 and N2. You invoke GCD to obtain the GCD. So with this function GCD, this is int GCD, int N1, int N2. With this function GCD, you can now reuse it for finding the GCD of any two integers. For example, I can have GCD for 30, 40. I can have GCD for 130 and 45. The function GCD is reusable. When you need to find GCD between two numbers, you're going to invoke it. So let's find the GCD between three numbers. So let's say I'm going to find GCD between this three numbers. So how I'm going to write it? So I can write it this way: GCD of 45 and 56. And now using this new GCD to find the GCD with 130. So this is to find the GCD of three integers. Let's look at another example here. Is to compute the prime numbers, to display 50 prime numbers in the preceding chapter. We put everything in one function. It is difficult to maintain. Using function, we can divide the big problem into several subproblems, and then use function to implement the subproblem. It isolates the problem if there is an issue with one area of the program, so we can concentrating on that area. So let's look at this now. We're going to write this program, prime number functions. So we're going to have one function is to test if a number is prime. So we're going to have this is the Boolean is prime. So we're going to test if this number is prime. So this is the number, is prime. So this function returns true if the number is prime. So how do you implement it? So we're going to implement it by looking at all the possible divisors. And if you find it, and then that is return false. Else, after this for loop, you did not find a divisor, and return true. So this is going to print prime numbers. So we're going to have this void print prime numbers. How many numbers are we going to print? So this is going to be int number of primes. This is how many prime numbers we're going to print. Now in the main, so we're going to invoke print prime numbers 50. We'll print 50, first 50 prime numbers. In this print prime numbers, we need to test if this number is prime. So we're going to check numbers 2, 3, 4, 5, and until we find 50 prime numbers. So this way invoke prime number. So the whole problem now is divided into two subproblems: print prime numbers and is prime. When implementing print prime numbers, we use the is prime function. That is all for this section. Modularizing code. See you on the next video.